Hello class, today we're going to be going over Module 15 homework, and Module 15 is on function composition. And function composition is where we have a function inside of another function. So we got multiple things going on here. So, number one, a spherical snowball with a radius of 6.4 centimeters when brought inside will melt in such a way that its radius decreases by a constant rate of 2 centimeters per minute. A, write a formula for function f that outputs the radius length r, measured in centimeters, when we input the time elapsed since the snowball started melting, t, measured in minutes. So, well, let's see. Our radius is going to be equal to the original amount, 6.4 centimeters, and then it melts, it decreases by 2 centimeters per minute. So we're going to have 6.4 minus 2t. Then B, write a formula for function g that outputs the volume v of the snowball, measured in cubic centimeters, when we input the radius length of the snowball r in centimeters. So this is just going to be the function for the volume of a sphere, which is given to us up here. So that's just going to be v equals 4 over 3 pi r cubed. And then C, what rule defines the function h, or what rule defines the function h that inputs the number of minutes since the snowball started melting and outputs the volume of the snowball in cubic centimeters? So we're given as h of t. So we want our output to be the volume, but our input to be the time. But look what we did here. We defined the radius to be equal to this. Right? Well, we have a radius in here, so how about we just plug in r in for r here? And that's what we're going to do. So we're going to have 4 over 3 pi, and then now r cubed, right? But r is 6.4 minus 2t. Awesome. And then D, evaluate h of 1.5 and explain its meaning in the context of the problem. So now we're just going to evaluate at 1.5. All right. So that's going to give us, after we simplify all of this, roughly 164.64. So what does that mean? It means that the volume is 164.64 cubic centimeters after 1.5 minutes. Because remember, our input was time, and our output now is the volume. So we can say after 1.5 minutes, the volume is 164.64 cubic centimeters. And we're talking about cubic centimeters because we're talking about volume here. All right. Moving on to number 2. Each function is a composite function in the form of f of g of x. Decompose the functions into two functions, f of m and m, where there is more than one possible answer. So we see here in the first example is given to us. Our composite function is 3 times x minus 1 plus 5. Well, m is going to be the x minus 1 portion. That's the inside function. And then our outside function is the 3m plus 5. You see, if you plug in m in for m here, then we'd get our composite function. So there are multiple ways of doing this. Generally, one way is more obvious than the other way. Here, for part B, it looks like the inside we could say is this x plus 4 business. So m is x plus 4. And f of m, we could say is m squared, right? If we plug in this x plus 4 in for m here, we'd get exactly our composite function. This next one here, we can let's see. It looks like our m is going to be the x plus 2 here. Because it looks like that's what's getting plugged in. So m could be x plus 2. And if m is x plus 2, then f of m is going to be m squared plus 3m plus 1, just like that. And if we're to plug m back in, you could see that we would get our composite function. Next, we have the square root of x minus 1, and to me it looks like our m could be this x minus 1, the inside portion, while our f of m could be the square root of m. Right? If we plug in the m back in, we get our composite function yet again. And then this next one, 500 over 100 minus x squared. Well, we could say that our m is the 100 minus x squared, and that our f of m is going to be 500 over m, just like that. So that's number 2. Let's move on to number 3. Many home builders in the Southwest use blown-in cellulose insulation to insulate the attics of new homes. Proper insulation is important because it improves air conditioning and heating systems efficiency and reduces the cost to heat and cool homes. One way to think about insulating an attic is to imagine the depth of insulation per bag applied to the floor of the attic. When hiring a contractor to add insulation to your attic, he provides you with the information in the following tables. So he shows you two tables. One is the function f, and the other is the function g. So the first table, it talks about the number of bags of insulation applied. So this is the number of bags, and this would be the corresponding depth. So at 11 bags, we'd have a depth of 2, at 2 inches. At 20 bags, we'd have a depth of 3.6 inches, and so on. The next table, the input is the depth of the insulation, so the output of the last one, and then the output of G tells us, okay, this is how much money it costs, or the estimated annual heating and cooling costs given a certain depth of insulation. So notice that the higher the depth of the insulation, the more efficient or cheaper the air conditioning and heating costs, the heating cooling costs. So let's take a look at A. Does the expression f of g of 9 have a real-world meaning in this context? If so, find the value and explain its meaning. If not, explain your reasoning. So let's see here. We start with the inside, so g of 9. So we're looking at our g function, and we go where the input is 9 and look at the output. The output is 1250. So then we want to go to our f function, our outside function, and look for the input of 1250. However, notice that our output of G is not the same as the input of F. The output of G is the estimated annual heating costs, while the input of F is the number of bags. So this actually does not make sense. We can say, let's see, does not make sense. And we can say that G of 9 represents the annual heating and cooling cost, while the input of F is the number of bags. So there is no real-world meaning here with f of g of 9. Okay, let's take a look at B. Does the expression g of f of 28 have a real-world meaning in this context? If so, find the value and explain its meaning. If not, explain your reasoning. So, again, we start with the inside function, which is this f of 28 business. So we want to look at f and see where the input is 28. Then, okay, look at the corresponding output. So the output is 5. Now we want to go to g, our outside function, and find the input of 5 and find its output. Well, we're in luck here because look at this. Our output of F is the same as the input of G. So this does make sense. So we can say, okay, F of 28 is 5. The depth of insulation is 5. And then go to G, look where the depth of the insulation is 5, and find its output. So, yes, this does make sense. We can say that F28 or F of 28 represents the depth of insulation and the input of G is the depth of insulation. So this does make sense. We discussed that F of 28 is 5, and we take that 5 and plug it into G. Well, G of 5 is $1,900. Therefore, G of F of 28 is $1,900. So what does this mean? This means that when 28 bags are applied, the estimated annual heating cooling cost is $1,900. Awesome. All right, and then part C, solve the equation G of F of N equals 1100 for N. Then explain what your solution represents in this context. Okay, so now we're working backwards. So let's see. We are given the output. So let's work outside N this time because we're solving for N. So let's see. 1100 is the output of G. Well, the input is 11. Okay, well now this is the depth of insulation, so let's go look at the inside function now. The output is 11, and the input is 61. So, if G of 11 equals 1100, well, and F of 61 equals 11, then N is equal to 61. And what does this mean in context? The cost, the annual heating cooling cost is $1,100 when 61 bags are applied. Just like that. Oh, sorry, I didn't realize I was going off the camera there. Sorry about that. Yeah, so G of 11 is 1100. Well, F of 11 is, G of 11 is 1100. F of 61 is 11, therefore N is 61. Okay. Let's move on to the last page here. So now here we're given two tables. We're given an F of X table and a G of X table, and we need to use the given tables to evaluate the following. So, F of G of negative 1, so we want to work our way inside out. So let's see, what is G of negative 1? Well, G, let's see, of negative 1 is negative 2. So now we're going to use the output of G of X as the input of F. So F is negative 2, or when the input of F is negative 2, the output is 3. So our answer is 3. What about G of negative 2? Well, let's just look at the G of X portion here. And we're going to say, okay, what is the value of G of negative 2? Well, that's going to be 0. and then we're looking at G again, so we're staying on the G table, and when the input of G is 0, the output is also 3. Awesome. So now, this is F inverse of negative 2. So this is going to be our output, and we're looking now for our input because of the inverse, okay? So I'm going to go to F. Let's see. Okay, where is the output negative 2? All right, it's right here. What's the corresponding input? Well, that's going to be 0. And then D, G inverse of F of 2. So let's find F of 2 first. Remember, we always want to start with the middle here. So F of 2, here's our F table. F of 2 is 0. So now we need to apply 0 to G inverse. But since it's G inverse, we're going to be looking at the output of 0 and look for the corresponding input of G. So here's where G is equal to 0, or G of x is equal to 0. So x is negative 2. All right. What about this next one? F inverse of G inverse of negative 2. So again, we're dealing with inverses again, and this time we have 2 inverses. So let's see. G inverse of negative 2. So let's look at our G and let's look at where the output is negative 2 and look at its corresponding input. That's negative 1. And then we want to apply that to F inverse. So go to where the output is negative 1 and look for the corresponding input. And that is at 1. Awesome. And then here, solve for x when G of x equals negative 1. So let's see. We have, so G of x is negative 1, right? So now we're working backwards here. So when G of negative, hold on. G of negative 1, wait, hold on. Sorry, my brain just exploded. G of x equals negative 1. Okay, so what that means is that we need to go to G of x and find out where the output is negative 1 and look at the input of 1. Now we're going to G of x again and look where the output is 1 and look for the corresponding input. So in this case, x is equal to 2. Just like that. So we found G of x, looked at the output, went to the input, and then since it's G of x, we're working with G again, so output back to input. And that's that. So that is the Module 15 homework. I hope this video helped. Have a good day. Bye.